In this videotape, what we're going to do is go through the objectives on the structure of vertebra and the vertebral column. So, in your objective sheet, these are objectives E, F, and G that pertain to the overall basic structure of the vertebra and the terminology associated with the vertebral column itself. As you're doing this, I personally suggest that you study objective G first, because that will teach you the general anatomy of the vertebra, and then go to the other objectives, objective E and F, that will pertain to it. So that's where I'm going to start. I'm just going to start off with talking about a vertebra in general. The vertebral column, of course, is made up of several of these individual bones, each of which is called a vertebra. There are different types of vertebra, obviously: cervical vertebra in your neck, and thoracic vertebra in the thoracic region, lumbar vertebra, sacral vertebra, and so forth. And one of the things I'm asking to be able to do is, like, if just an individual vertebra is lying there, to be able to identify what kind it is. Like, is it a thoracic vertebra, or a cervical, or a lumbar, that type of thing. And if you know your general overall anatomy of a vertebra, then that's really quite easy to do. So, to begin with, I want to point out that this large piece of the vertebra that I'm hanging on to, this is the body of the vertebra. Now, this is the main weight-bearing portion of the vertebra. And when this vertebra articulates with the vertebra above it or below it, then all these bodies are all going to be lined up, so that if you view the entire vertebral column, you can see how all the individual bodies of the vertebra are such, and they're all on the anterior side of the vertebral column. This is going to be the main weight-bearing structure of it. You also see how those bodies are so very much thicker down here in the lumbar region than they are in the cervical and thoracic region, which shows that this is where the greatest amount of stress on the vertebral column is at. It's where most of your weight is borne upon it. To give flexibility, nature also has pads, not of felt like on this specimen, but pads made out of cartilage between each one of the bodies of the vertebra. These pads of cartilage are referred to as an intervertebral disc. Again, the prefix inter for between, intervertebral disc. And as you can see, they make up probably, if you add them all up, they make up probably about 1/3 of the total length of that vertebral column. As you get older, these intervertebral discs become thinner, causing the bodies of the vertebrae to end up being shorter or closer together. And this accounts for why many of us get shorter as we become elderly. It's because of thinning of these intervertebral discs. But these are our main shock absorbers to bear up upon compression forces and so forth. In order to do that, nature has designed them so that the very inside of these intervertebral discs has a little pad made out of a gelatinous type of material called a nucleus pulposa. And that's really where you get your cushion effect, because the more peripheral areas of the intervertebral disc is fibrocartilage, but it's the inside core that is the gelatinous nucleus pulposa that is actually the cushion. And sometimes the fibrocartilage periphery of the intervertebral disc will become weakened. And upon being weakened, then excessive compression forces then can cause that interior gelatinous nucleus pulposa to bulge outwards. And usually when it bulges outwards, it bulges laterally. And the bulge then of that gelatinous material is going to put pressure up against this thing. And this green thing that I'm putting pressure up against mimics a spinal nerve, of which you see a number of these spinal nerves all coming out laterally between the individual vertebrae. Well, this is where you get all the pain and the partial paralysis and loss of sensation of the extremities associated with a common back disorder, a slipped disc, or herniated nucleus pulposa, or a variety of technical terms that this condition might be called. While we're here, you also see that there are openings between each one of the individual vertebrae. And it is through these openings that the individual spinal nerves come out from the spinal cord and will go out to the individual body areas that they innervate. These openings that spinal nerves come through are the intervertebral foramen. Again, inter for between, intervertebral foramen. Now, if we go back to the individual vertebrae to take a look at its basic overall structure. So I picked out this vertebra just as a representative here, and here it is with its body. Now remember that the body is always anterior, so I'm holding on to the anterior aspect of the vertebra. Now we also have an opening that I just put my finger through, vertebral foramen, not to be confused with intervertebral foramen that I just talked about. It is through this foramen here that the spinal cord passes through. So imagine that my finger now is mimicking the spinal cord. And you can see how the spinal cord is going to be protected anteriorly by these very large bodies. Now then, if you take a look at the posterior side of the vertebra, and again I'm going to leave my finger in here as a reference to the spinal cord, then we end up having a plate of bone here and here that I'm just running my fingers across, called the lamina, and it is the lamina of the vertebra that is covering the spinal cord posteriorly. If they ever need to do surgery on the spinal cord, they have to do a laminectomy, where they would make a cut here and make a cut here and then remove this portion of the vertebra. And doing that, then my finger, the spinal cord, is going to be exposed. In the very center of the lamina, there's a very large projection that's going to project posteriorly. This is the spinous process of the vertebra, or you can simply call it the spine. Now, if you were to curl up in a fetal position, or have a friend curl up in a fetal position, then you can feel all the spinal processes except for the first 6 cervical vertebrae. And if you start going down midline on your neck, then the first big bump that you feel right in the back of your neck is the spinous process of the 7th cervical vertebra. And then from there on caudally, you can count each individual spinous process. Then the 2 projections that extend out laterally are transverse processes. So what we've got from a posterior view is you can see the transverse processes, the spinous process projecting out posteriorly, and in between the lamina. Now then, if I tip the vertebra up in this direction, again keep in mind that the spinous process is posterior and the body is anterior. The transverse processes are projecting laterally. Then notice that we've got a plate of bone here, get something to point with here, and likewise here on the other side, which, if you use your imagination, it kind of looks like you now have a bird perched on something solid, and these are the feet of the bird. Well, pedicle means foot, and so therefore this portion of the vertebra is the pedicles of the vertebra. So we've got a body, and we've got spinous process, transverse process, and lamina, and all of this portion is attached to the body by means of pedicle. So if you now turn and look at the vertebra from a side view, then it is the pedicle that is covering the spinal cord on the lateral view. So your spinal cord is protected throughout its entire circumference by the body anteriorly, by the pedicle laterally, and by the lamina posteriorly to protect that spinal cord. Now, these are the basic features that all vertebrae have, no matter what type of vertebra that they have, or that they are. However, we do have different types of vertebrae. We've got cervical vertebra in the neck, thoracic vertebra in the thoracic region, lumbar vertebra in the low back, and sacral vertebra and coccygeal vertebra. There is some basic differences between each.